We are starting in Adobe Illustrator to review graphics that represent our project's points of interest, the teleportation locations on the map. I'll cover best practices for exporting images for import into Unreal Engine. Then we build a new UMG widget to contain the points of interest graphic, as well as a new enumeration so when our player clicks on the POI widget, it teleports them to the correct place. We then create a new Blueprint Actor class that acts as an in-level locator for the teleportation. As mentioned, I'll be using Adobe Illustrator to design the UI. Feel free to use any vector-based program for UI designs. If you are unaware of what I mean by that, search for vector versus raster programs in your search engine of choice. Despite the minimalism of our project goals, always have a plan. In our user interfaces case, it's a simple one, but it's a direction for us to head in. I've taken a screenshot of our map and designed what I would like the buttons to look like and where they should be located, as well as the map points. I'll place the points of interest circle onto its own artboard and do the same for our cursor. Make sure your artboards are named identifiable names. This organization will come in handy when you need to make changes and re-export. To export assets using artboards in Illustrator, use the shortcut Ctrl-Alt-E or go to File, Export, Export for Screens. The format of the export is very important. Become familiar with different image formats and what makes them different. I'll be exporting as a PNG and importing these to our project into a new UI folder within the Textures folder. Create a new widget in the reusable folder named WMapPoint. Here, I've replaced the default canvas panel with a size box and placed a button in. On the button, I've placed an overlay and an image. I created the overlay on the button so that we can have multiple images for an animation of the circles pulsing. For now, though, we'll just have them static at different scales. Add the eMapPoint as a variable to this WMapPoint widget and make it instance editable. Also, add an instance editable Boolean variable so we know if the point is a balcony point or not. Finally, we need an isActive Boolean variable to determine if it should be visible. Let's create a blueprint named BP_mapPointLocation. We'll distribute these around the map to our locations we will be able to teleport to. They should contain a simple cube with no collision and an arrow so we know which way it is facing. Be sure to add the eMapPoints variable and make it instance editable. Lastly, on Begin Play, destroy the cube as we only needed to see where to place our map points in the widget. I've distributed them around our map and set each enumeration value to the correct value. Make sure that you have placed our BP map point locations pivot points directly on the floor as our logic will use that point as the transform of where to teleport you to. Go back to our W top mode and place the W map points into the canvas panel and directly on top of their 3D counterpart. Now that the points are all in, open up the map point widget. We are going to have our top view default to showing the ground, which would have balcony points inactive and hidden at the start. Place that logic in after event preconstruct. And now any W map point in your top mode widget that has isBalcony set to true should be hidden. Let's set up the first action of our main button. From a switch node inside of WC main button, drag off switch 2 and get all widgets with our BPI Studio Showcase interface and add a for each loop calling W toggle balcony. To implement an interface on a widget is the same process as an actor. Go to class settings and add the interface, then compile. Add this W toggle balcony event to the various widgets that will need to update something when that button is pressed. The map points need to hide and unhide. The user button needs to toggle what it says. And the W top view needs to convert the call from a widget interface call to an actor interface call. Now the BP scene capture can receive it and update the height variable and show only list. Let's test all these changes in VR. Spawn the map and click Switch to Balcony. There we go. The map point swapped, the button now says Switch to Ground, and the scene capture adjusted the show only list. And switching back works just as well. We now have the points of interest logic in place, and the interaction with the map and level is working. Next, we build the teleport logic that we use to get the player from where they are to where they want to go.